Hello everybody, welcome to Unacademy classes.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So once again, hello to everyone and welcome to Unacademy classes. My name is Abhishek Mishra and in today's class we will be doing revision of metal forming and we will be mainly focusing on the formula and the numerical parts of the metal forming topic, and I will be sharing with you the tips and tricks as we go on discussing this metal forming. So first of all, I would just like to inform you that GATE Combat registration is just going on, and GATE Combat is going to start from just today. So 16 December, that is today, and 6 p.m. you will be going to have this GATE Combat. So just register and just score good there and win prizes, and also just learn from your mistakes that you are making by seeing the detailed solutions. So let's begin today's class. I have secured all India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT VHU Varanasi. I have got good teaching experience of 2 years in mechanical engineering subjects, and some of my interests are photo editing, video editing, cricket, football, and I like all sorts of games. So I will be taking this entire class in English, and I will also be just giving you tips and tricks, because that I think is very important when you are preparing, and you can just prepare from your notes and all these things, but my class is giving you this extra information in the form of tips and tricks that I have accumulated over the years of my preparation and my teaching. So just attend this class and just focus here completely, and I think after you have completely attended the class you will find yourself prepared better than you were before. So it will be the time you spent here will be worth it. So you can follow me on unacademy.com. So after following me there, you can watch classes, download the PDF that I am going to share, or that my classes have in the Unacademy's website, and also you can watch or view my schedule that I will be following, and I am also starting thermodynamics soon, so just keep an eye on that. And you have to use this code to access free classes on Unacademy app and website, so just note it down, and you can also get 10% extra discount after you are using this code. And today is the last day to just register for Unacademy Combat, that is quiz, and this is the code that will be needed to register in that quiz. So just note this code down, and this is Unacademy Combat. So Unacademy Combat you can enroll for free, but again you will need the code, that is ABHIMI, and after you are just enrolled, registered, you can just complete the quizzes, attend the quizzes, and according to your rank you can get either MacBook, Apple iPad mini, Apple AirPods, or the top 100 rankers will be provided with rupees 1000 Amazon vouchers also. So overall, this gifts or prizes that you are getting are guaranteed. So if you are going to score this rank, then you will be guaranteed getting this prizes. So I think this is a win-win situation. And if you are just giving this quiz, then not only you are going to prepare and learn from what the quiz will offer, but also you are going to win. So this is just 16 December is the date of this Unacademy combat beginning. So just keep just keep this code, use it, and register here. And you have to download Unacademy app so that you can assess the quiz and all that. So Unacademy app is again free to download. You just have to go to your respective app store, Play Store or Apple App Store, and just download this app. So this app is having a lot of features, and if you are using this app already, then you should explore what features this app offers. And I think you will find a lot of good quality things that you can just use to get your preparation in a more better way, do your preparation in a more better way. So just see what this app offers. This app is a complete package. It is offering everything that you are that you require for your online preparation. So just check it out. So what you will get when you subscribe to Unacademy: daily live classes, live test and quizzes, structured courses, unlimited access. So when you are subscribing to Unacademy, you are getting your money's worth from the moment you have subscribed. How? Because day in day out there will be live classes held there, which you can just attend, ask your doubts, answer polls, all while the class is going on. And you will find the level of interaction that a Unacademy class has, or that an class which is happening on Unacademy has, is far superior than anything on YouTube, because the way Unacademy website or app is designed is specifically keeping in mind the educational purposes. And unlike YouTube, which is general video streaming site, the Unacademy is offering you these tools, and also they are offering these tools to the educator, that is me, so that I can take the class more properly. And live test and quizzes, as I have told you about Unacademy Combat. So similarly, a lot of test and quizzes will be there. Full length test series is also there, and this will help you evaluate your performance. And not only you will be just giving test and moving on, you will be provided with analysis which you can just see and just check out to see where your performance is lacking and where you have to work on. So you should totally use this analysis. And there are structured courses, unlimited access of content when you subscribe. So Unacademy is giving you subscription at this reasonable price, which is shown on the screen. No cost EMI is available on 6-month and above subscription plan. And if you enter the code ABHIMI, then you will get 10% extra discount, which will make the subscription prices this, which is the least possible price one has to pay to get an Unacademy subscription. This is for plus type of subscription, which is basically classroom type experience. And again, this price will give you not only the live classes, but also the notes, the recorded classes, the quizzes, live quizzes, and the test series, which will be full length, and you will be provided with detailed analysis also. So this whole thing you are getting, which will just help you a lot in your preparation when you subscribe to Unacademy. So just subscribe here and start your preparation, because around 2 months are left, and there are a lot of new courses starting in the Unacademy's site and the Unacademy's YouTube channel. So I just think that you should subscribe to Unacademy and assess that courses, crash courses or revision series, and learn as much as you can from that, and give as much test as you can. And by doing this, I think you will find yourself in a very better position, and you will find that you are going to score good marks due to the things that I have told you, like crash courses and test series. So now just make your aim that you are going to attend this crash courses, and you are also going to just do the test series and learn from both of them, and properly study for around minimum 5 or 6 hours, and or 5 or 6 hours can be fine. You can study from that. If you are following an academy, you are going to do it efficiently. So I think 5-6 hours study for 2 months will make you very well prepared for GATE examination, and it is now then up to you how you can score, because the way you are preparing, the things that you are just accepting and learning will depend upon you, so that you can just be more attentive about, and just subscribe and start your preparation. And there is another Iconic subscription which is for those who need more assistance, and here are the discounted subscription plan prices of Iconic subscription. Again, 10% off code ABHIMI you can enter here, and no cost EMI is also available in the Iconic subscription type. So Plus and Iconic subscription benefits are shown on your screen. If you need personal coach, personalized test series, they will guide you properly. So 2 months are left. If you are thinking that you need better preparation, then just select the personal coach and personalized test series, study planner, preparatory study material, all these things for 2 months, and you will be then guided by this personal coach for your interviews, for your other exams. So Iconic is very well subscription to choose from, and I think if you are having this need, if you are want to just prepare in this manner, then you should totally go for Iconic. It is very well worth, and this Plus subscription are for those who are just okay with the classroom experience, who are already preparing, who are just familiar with this classroom experience. So they will find this Plus subscription type very beneficial for them. So just choose one of the subscription type, use this code, and subscribe and start your preparation. So let's start today's class. In today's class we will be talking about the metal forming, and we will be doing the revision of the metal forming topic. So first of all, in metal forming, let's talk about cold working and hot working. So I will not waste a lot of time in this topic, because here you only have to know some things that I am going to discuss here. The first thing is that cold working is the manufacturing process or metal forming process in which you are doing the metal forming or plastic deformation at a temperature. Working temperature here is less than recrystallization temperature, and working temperature here is greater than recrystallization temperature. So this is simply cold working and hot working. But what is recrystallization? Let's talk about it here. So in recrystallization, what happens is, in recrystallization, let me just write it here. So in recrystallization, you are going to a temperature, for example, let's say 1000 degrees Celsius, and after you have reached that temperature, you are going to see that new equiaxed stress-free grains are forming. So when reaching recrystallization temperature, just remember this very important point that I am going to write it here. You have a stressed grain, and if you are doing recrystallization, then you are making this stressed grains equiaxed that is spherical in shape, stress free grains. So see, you have first of all a stressed grains which will have low ductility, and I should also write here FINE, fine, because your grains will not be that big in size. That will be fine equiaxed stress free grains, and ductility here will go up. So recrystallization, what is happening, you have this stressed grains which you want to make equiax stress free. By making that, you are going to make that grains ductile, and you are doing recrystallization. So you are for example, if recrystallization temperature is 1000 degree and you are making that material or metal piece go to 1000 degree, then new grains will start forming which will be stress free, and your stressed grains will be converted into this stress free grains, so its ductility will go up. So that is what is generally happening in recrystallization. Your stress grains having low ductility is being converted into stress free grains having higher ductility, and also there are new equiaxed grains forming which are fine in size. So this is recrystallization, and that temperature, the working temperature of hot working is greater than this recrystallization temperature, and therefore we can say that recrystallization will occur during hot working. So there is one more question that was asked in GATE examination, that where the reduction or deformation can be more. So it will be hot working, because ductility of hot working is greater due to recrystallization, and cold working you will find strain hardening and things like that, that will reduce its ductility. So we also have this recrystallization versus annealing discussion that we have to do. So before doing that, let's discuss about strain hardening. So strain hardening occurs during cold working. So strain hardening is just there when we are doing cold working, and what it is doing. So example, you have this grains which are like this. So I should just convert it into, draw it into more appropriate shape. So this grains, when you are doing cold working, you are going to find strain hardening making this grains elongated stressed grains. So this is what cold working is doing. It is making this grains which are not that much stressed, which are having some good ductility, to be cold worked into the stress grains where ductility will be reduced and their strength will be going up. So strain hardening makes strength to go up and ductility to go down. So what this represents is, after you are just having this strain hardening in your workpiece or metal piece, you will find further deformation of the same metal piece which is now strain hardened difficult due to its ductility being reduced and strength increased due to the phenomena that is strain hardening. So strain hardening phenomena just does this thing, and how it is occurring, it is just due to the fact that the cold working process is just making this grains shape different, and this shape will account to this new properties. So let's discuss now annealing versus recrystallization. So before doing recrystallization versus annealing, let me just tell you very important point here. It will take a minute. So let's discuss that here only in the annealing versus recrystallization discussion. So recrystallization has this recovery then recrystallization phenomena, and annealing has recovery, recrystallization, and then we have grain growth. So after you have done this recrystallization, you will find that your stressed grains that are there due to cold working or there at the start will be converted into equiaxed stress free grains, or I should write here output. Output simply means what we are getting at the end. So at the end we are also getting here equiaxed stress free grains. So just notice that this equiaxed stress free grains we are getting here both, but recrystallization is not having the last step grain growth which is there in the annealing. So obviously this will make some difference, and that difference is this whole equiaxed stress free grains will be coarse due to grain growth, and this will be fine or small. So coarse, or I should write large here, and there will be fine and small or small. So this will affect some things a lot. For example, the ductility here will be ductility. This will make ductility very high, so very soft workpiece. So this can be taken as a negative also, because you don't want your metal piece to be so soft that it just loses its strength that is required. So recrystallization is perfectly fine. It is followed when you need this equiaxed stress-free grain which is having a proper ductility and also good amount of strength. But if you are wanting ductility to be even more than recrystallization, and therefore you want this coarse grains, then go with annealing, which will have grain growth as its last step, which is not there in recrystallization. And what recovery does? Recovery first of all converts these stress grains into equi-X stress-free grains, and recrystallization is just making new stress-free grains at a temperature which is recrystallization temperature, and then we are having grain growth which is only there in annealing, which is making the fine grains obtained from recrystallization into coarse grains, and this has been done by making the annealing process above the recrystallization, and after the recrystallization has been done, the temperature is kept above the recrystallization temperature, so to allow grain growth and make this coarse grains. So just these are the two differences, and just remember this small points that I have pointed here, so that you can just completely differentiate between these two process. And sometimes numericals, not numericals, objective questions come where there is asking that you need grains to be fine, so which process you will just go with, and then you will have to go with recrystallization because annealing is having grain growth as its last step. So now we are going to talk about formulas in rolling. So formulas in rolling is what we are going to talk now. So to do this, I need the rolling figure, and let's take it from one of the images that I have here. So let me do that. So let's see, we have formulas, what formulas we have in rolling that we have to just know and remember. So first of all, this is your rolling operation. So as you might know, and you should know because this is revision, that this in this operation you are making this metal piece go between this set of rollers to change its thickness. So its thickness is getting changed due to it being passed between this set of rollers. So first of all, you are going to see this contact length. So this length where the metal piece is in contact with the rollers is the contact length, and the angle that this contact arc or arc of contact is making with the center of roller is the angle of bite. So this alpha is angle of bite, and in numericals you will be asked to calculate angle of bite. So if the roller is having diameter d, and if its initial thickness is hi and final thickness is hf, so reduction will be, which is also known as draft, this will be delta h, that is h initial minus h final. So this reduction or draft is delta h, and the cos alpha, which is the formula, or by this cos alpha you are going to get the alpha, that is bite angle, is given by 1 minus delta h divided by d. and you can find this by drawing here the perpendicular bisector and just getting a right angle triangle, and then just getting this cos alpha is equal to 1 minus delta h divided by d. So that thing is not necessary, and I don't think that till now any GATE question is using the having the use of the derivation to do a question. So just remember this formula, that is cos alpha is equal to 1 minus delta h by d. Then we are going to have this for unaided rolling, that is there will be friction acting when this rolling operation is going on, and that friction will be acting between the workpiece and the rollers. So that friction will make this rolling operation go unaided. What this means is that that friction will make this workpiece pull this workpiece into the gap of this rollers for the rolling operation. So without any help, this friction will itself do the job of pulling the workpiece and hence doing the rolling operation, and this is therefore known as unaided rolling. And for that you need to have the coefficient of friction greater than or equal to tan alpha. So if coefficient of friction is greater than or equal to tan alpha, where alpha is the bite angle, then you will be having this unaided rolling. And then the other formula here is maximum draft. So delta H maximum will be given by mu square into R, where mu is coefficient of friction between this rollers and workpiece. So let me just clearly so this is the first formula, this is the second formula, and this right here is the third one that you have to remember for rolling operation. So rolling operation has this three formulas that you need to just remember or know to do the questions that is asked in GATE examination. So first is just this cos alpha is equal to 1 minus delta h divided by d. Then for unaided rolling, your coefficient of friction should be greater than tan of alpha. Then for this delta h max, that is maximum draft or reduction, you should have its value calculated by using mu square into r formula. So this is rolling operation formula, and then we are going to study about the forces there that are there in rolling and how to calculate them. But before doing them, let me see that if there is one more formula, and let me just and this delta h max will be h initial minus h final, which will be minimum. So this is your rolling operations maximum draft. Then we are going to discuss about the elongation factor, because that is one that is left here to discuss. Then we are going to discuss about the rolling forces, which is also important. So there is one term here, elongation factor. Elongation factor E is equal to L1 divided by L0 is equal to A0 divided by A1. So you can see this all is greater than 1, because the length will be increased and area will be decreased. So we are going to take elongation factor by doing this big by small, and this elongation factor E is equal to this. So that will be it for elongation factor. Now let's discuss about the forces that are there in rolling. But to do that, to do this discussion here, we need this figure again. So now, rolling operation as discussed before, let me just draw it here again. This rolling operation is having this angle made by the arc of contact alpha, which is the bite angle, and this arc of contact, when we are going to take its projection on a horizontal plane, then we are going to find that this arc of contact is having this length. So this is known as projected length, and this is equal to under root of r delta h. So this r delta h under root will provide you this length, projected length, which is going to be useful when we are doing this force and power calculation. So just remember this thing, that projected length is equal to r delta h, and remember that this is radius, not diameter, and it can also be equal to r sine alpha. So this is also a formula, but I think this will be enough, and till now this is the only formula that I think is come in use to calculate this rolling operation, force and power. So just study this. So but you can also remember, so let me just not erase that. And then you have the projected area AP, which will be simply LP into B, and in mm square it will be, and this LP into B will be, this LP into B will be the area, and that area is calculated by multiplying this projected length into B, which is the width, and this width, by the way, is not changing in this rolling operation because the change is negligible. So we are just ignoring that change, we are just not accounting it because of that negligible change. And then we have the force F, rolling force, that is also known as roll separating force. This roll separating force F will be the pressure or the strength into the projected area, and you will find this in Newton, because this will be in Newton. Usually this is given in Newton per mm square, and this projected area will be given in mm square. So you can find the final force that is there in rolling, that will separate this, that will try to separate here the roller and the workpiece, is roll separating force, is just this sigma into AP newtons. Then you have arm length, and why arm length is important. So first of all, arm length. So arm length is nothing but A is equal to 0.5 LP or 0.45 LP. This is for hot rolling and this is for cold rolling, and you are going to take this hot rolling by default if nothing is mentioned. And this arm length, when multiplied by the force, will give you the torque, and divide this arm length by 1000 so that you can get your torque in Newton per meter, because this LP will be in mm, so your A will also be in mm, and if you are doing calculation like that, then just divide it by 1000. Then we have this torque per roller. Let me write here, per roller. So after that I am going to write at the bottom what will be the power, total power. It will be 2t omega in watt, and this 2 is due to 2 rollers. So this is total power. So you are going to give the power that is being given to this rollers, both rollers, and that total power will be 2t omega, that is 2 into torque into omega, where omega is the angular velocity of the rollers, t is the torque per roller, and 2 is to account for 2 rollers. So this is the whole formulas or whole process to calculate the total power in the rolling operation. And again, just remember that F is roll separating force, and sigma is the flow stress which is required to make this plastic deformation occur. So let me just write it here, sigma naught, because that usually how flow stress is denoted. And these are the things that you have to remember. And again, one of the gate question which was asked has used this entire procedure, or a lot of gate examination, if you just consider the conventional paper also, is using this whole total power steps to get the answer or to ask the answer. So you have to remember each one of them, each one of the steps. And also total power is 2t omega, so don't just miss the 2, because you have to give the power for both the rollers if simply power is asked, or if there is being asked that you have to provide power for each roller, then you can not then consider 2. But if it is not asked, then by default you are going to consider 2. And also by default you are going to take arm length as 0.5 lp, because hot rolling is the process that we consider by default. So now let's discuss about forging formulas. Then we are going to discuss about extrusion and drawing formulas, and after that we are going to discuss about the deep drawing. There is only one simple formula there, sheet metal operation formula. So these processes are having very not very that large amount of formulas, so we will just see them and just move on. And then what I will do, I will just make you do, or doing questions is not required because I have already done that in my previous class, so I will not do that here again. I just want you to just simply relax and just see the formulas that are I am showing here, that are important for your metal forming. So formulas in forging. So in forging operation, you are going to you just should know about the power law of strain hardening. So that power law of strain hardening, this is having the formula this K is strain hardening coefficient, and this N is strain hardening exponent. So here I have written T because whenever you are going to use this formula, you are going to use true stress and true strain here. So you are going to use true stress and true strain here in the power law of strain hardening. And remember this, that N is equal to true strain at ultimate tensile strength. So at ultimate tensile strength, the value of true strain there will give you the value of N, that is strain hardening exponent. So if you are given with this sigma engineering strain and engineering stress, so I should write it properly here, and engineering strain as epsilon, then you need to first of all find the true strain using this formula. It will be sigma ln 1 plus epsilon. Then you are going to find the true strain using this formula. L final divided by L initial, and you will be provided with this both true strain and true stress, which you can then use into this power law of strain hardening to calculate either this K or N. And this power law of strain hardening can also be used to calculate the flow stress, which is the stress that is required to do this forging operation, that is required to do the plastic deformation via which your this whole metal forming is going to occur. So let me just provide you one more detail here. So yes, I should also mention that similarly that this sigma true is equal to sigma ln plus v. This true strain is simply also equal to ln 1 plus epsilon. So this is also one of the ways to do that, and you can also write it here, area initial divided by area final. Just remember that the final length will be at top and initial length will be at bottom, but final area will be at bottom and initial area will be at top. Let me just check out if I should also mention one more thing that I am thinking about or not. So yeah, that will be it for this discussion of power law of strain hardening. And yes, I should mention here this thing, that the yield strength and the ultimate strength, in between both of this will have this flow stress, which is required for this plastic deformation. So just remember this formulas that I have provided to you, and you can watch my previous class of metal forming to see how to use these formulas. And I have also shown you here, just given you hint, since this is revision, so we are only going to do this and move on. And to do the questions, just see my class again. I am mentioning because it is recommended for you to just see the class here, revision class, and then do questions to get better grasp of the topics. So now we are going to talk about extrusion and wire drawing. So extrusion is having this formula where the force will be given by flow stress into pi by 4 d naught square into ln of initial area divided by final area, or it can also be and this is extrusion force, and wire drawing force will have this formula changed a little bit, where we have this flow stress into this final diameter area square, and then this will be same A naught divided by AF, and here it will also be same. So these are the forces of extrusion and wire drawing, and this both you have to just remember. And if you have been asked about the calculation of the extrusion stress or wire drawing stress, just take this area or divide this area with this force formula, or this take this area here, then you will find the stress. So that stress, let's write that also, because after that I am going to discuss an important thing there. So you can see here that both the stresses are going to have the same formula, because you are going to divide them with the respective areas of there. In extrusion we are taking the initial diameter, because we are pushing that, we are having that diameter in contact with our ram or plunger, which we are using to push it, so that it just flows forcefully. We are flowing that to die opening, therefore that is the area in which we are applying force, therefore we are taking it here. And in extrusion we are pulling it, so we are applying force on the DF, and therefore is the area that we have taken here. And this is the extrusion and drawing stresses, which both are equal. And let me just tell you very important point, that when we are going to find this, so let me just provide you detail here, but before that let me just provide you one more information. So yes, I was going to say this very small thing. If you are instead of this stress here, this sigma naught flow stress here, if you are provided with a what its name was, so if even instead of it, if you are provided with a value k, strength constant, then that value k will take into account the real life conditions. So you have to just multiply or just put the k instead of sigma naught. That k will be having the same units, it is just a stress, but it is taking into account the real life things that will just be there. So it is not something that you can just worry about. It will be similar to the whole formulas that I have shown here. So if you are given in the question to find out the maximum reduction then this maximum reduction in wire drawing or in extrusion can be calculated by putting this extrusion stress or wire drawing stress equal to sigma naught. So you will find this will become equal to sigma naught, so this sigma naught, and from this you will find that this maximum reduction can be calculated by doing this process, by making this ln a naught by af equal to 1. So there you can find that maximum reduction. So just calculate it when you are doing the revision on your own, because that thing is just simple calculation. This whole ln a naught by af is equal to 1, so a naught by af will be equal to e. So now let's discuss about the sheet metal operation. So in sheet metal operation we have some clearance between punch and die. So for blanking, operation, clearance given, or I should just write clearance on punch so for blanking you are going to find, let me show you the figure, or let me show you one figure that will just give you the difference between punching and blanking. In blanking, punch size will be, after taking into account clearance, and die size will be equal to the size of the blank and or the disc. And in punching, the hole size will be equal to punch size, and the die will be provided with some clearance. Let me just show you that here. So as you can see in this figure, so let me just do one thing. So as you can see in this figure, in blanking, the workpiece is this blank or disk, that is the object that is removed from here, and the scrap is rest of the workpiece which is left. And in piercing, the workpiece is this sheet which is left with holes, and this part which is removed is scrap. So both blanking and piercing or punching is having this different things as workpiece and scrap, and this figure is clearly showing what they are. So for blanking, the punch size, so I should write punch here, and for die here, die size minus 2 times of clearance, and punch size will it should be punch, and die size will be the size of blank or size of product. And for punching, the punch will be size of hole, and die will be equal to size of hole or punch size plus 2 times of clearance. So why clearance is provided? Clearance is provided to make sure that you are having this proper cutting without just getting your punch and die stuck there. The proper clear cut will be provided only when there is clearance, and this clearance C can be obtained by a lot of different ways, and let us discuss that here. Then we will talk about the sheet metal operation force, punching force or blanking force. So first of all, that clearance C is given by, where T is thickness and tau is the shear strength. Or it can also be given by the alloyance A into the thickness of metal. So this is alloyance. Or C can be also given by the percentage of clearance into thickness. So thickness is always present in all these formulas, so you have to just consider that. And then you have the other thing here, that is the punching force or blanking force. So this punching and blanking force is given by F max is equal to L, that is the length is which is in contact with the punch, T thickness, and tau is the shear strength. So this will give you in Newton the punching force or blanking force, which will be the maximum one. And there is one thing we do to reduce this maximum force. We apply or we provide shear, so that shear on punch will be S, and this is punch, for example. So this is your shear S. So this shear S will make this total shear on punch S will reduce the maximum force, but the total force will be same. And this shear of punch so if no shear, then you are having this force versus displacement curve like this. So the maximum force is here, you can see quite large. And if you are having shear, so with shear you are still having the same area, but the maximum force will be reduced and your graph will look like this curve. So maximum force here is reduced, it will become trapezoidal instead of this triangular, and hence the area will be same area, therefore same energy. Since the area is same, the energy is same, but the maximum force is reduced, so that is why the shear on punch is provided. And that shear force is calculated using this formula, or F is calculated using this bottom formula also, and I will just mention here when these two formulas are used. So you have this same formula, and remember here that why we are getting this less force here, because the distance here traveled by punch is more when we are providing shear on punch. So when we are providing shear on punch, the distance will be more, and that is making this maximum force to go down. So this first formula you will use it by default when there is a circular hole mentioned, and if it is mentioned that your force versus displacement curve is trapezoidal, that like we have shown in the graph here, so you can then use the second formula. but just make sure that if you are using one of the formulas and you are not getting answer, then just check the other formula if it is getting the answer which is matching in the option, and then use that and provide the answer, because it depends upon examiner also. So let's now talk about deep drawing. There is one simple formula in deep drawing. So the deep drawing formula is, you are having this blank of thickness T and the diameter capital D, and from this blank you are making this cup. So this cup is having still thickness T, but here this cup is having height h, and this diameter will be small d. So in deep drawing questions you will be asked that what is the blank size, initial blank size. This is blank, this is cup, from which you are making this cup. So d will be under root of small d square, that is diameter of cup square, plus 4dh. So this is your deep drawing formula that you have to remember. There is force calculation formula also, but I don't think that yet a GATE question has been asked from that formula. So just remember this formula and remember how it is coming from. This volume will be equal to, volume of blank will be equal to volume of blank will be equal to volume of cup. So from here you are getting this deep drawing formula. Next, after deep drawing, what will be left? Let me just check out. I think only one thing is left, that is the stretch forming. So yes, there is one more thing, spinning. So for spinning you have to just remember that final thickness is equal to initial thickness into sine alpha, where alpha is the half cone angle. So alpha will be the half cone angle here. Yes, it will be half cone angle here. So just remember this. Then we have a stretch forming. So in stretch forming, what you are going to get asked is, you are going to have this workpiece of thickness T, length L1 and L2 as breadth or width, and this will be getting converted into thickness T dash, length L1 dash and width L2 dash. So in stretch forming, just remember that this L1 L2 into T is equal to this L1 dash L2 dash T dash. So from here you will be asked for final thickness T dash, that will be equal to initial thickness T divided by e raised to the power epsilon 1 into e raised to power epsilon 2, where epsilon 1 and epsilon 2 are the two strains of this both the lengths. So this will be ln L1 dash divided by L1 ln L2 dash divided by L2. So this will give you this final thickness value, and how you can see from the formula that I have shown you. So stretch forming is this, and remember that L1 and L2 will be converted into L1 dash and L2 dash, and you have to consider this true strain formula. So this is true strains. And at the last here we are going to discuss about bending. So this bending will be having this formula of bend allowance. So bend allowance is LB equal to alpha R plus KT. So this alpha will be the bend angle, and this R will be the bend radius, and this K will be the constant, that is a stretch factor, which will be given in the question, and T will be the thickness of material. So that will be it for the formulas here for bend allowance. It can be asked, and remember that here biaxial compression and biaxial tension will be the state of stress of the material undergoing bending. So that's it for the formulas of this class. You can follow me on unacademy.com so that when I start classes there, you can attend. Today there is some type of work going on, more specifically painting, so I am just taking this class very quickly, and just follow me there and use this code to watch free classes on Unacademy's app and website ABHIMI. And again, I will be taking an entire class of mine in English only, so you can just attend the classes and just join the Unacademy's register for the Unacademy's combat. I will show you the video again, and use this code to get 10% off. There are multiple crash courses occurring, so you can just use them and just join them after subscribing to Unacademy, and hit the like button if you found the class helpful and engaging, and subscribe to this channel, hit the bell icon for notifications, and let me just show you the Unacademy combat video.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So Unacademy Combat registration is going on, and you can register for it. 16 December it will start, 6 p.m. that is today. So just go register to the Unacademy Combat and give the quiz there, and just win prizes. And also, after giving the quiz, see what mistakes you are making and learn from that mistakes, and see the solution by viewing the detailed solution provided by Unacademy, and use this code to also subscribe to Unacademy. Just join the Unacademy Combat by using this code. So this code is giving you free access to the classes in the Unacademy's website and app, and also on the app you are going to get this Unacademy Combat after just using this code, and you can get 10% off by using this code. So all these things are the benefits provided by using this code. So just note down this code and use it, and join me on the Unacademy's website. Follow me there so you can attend my classes there, and this is the link. You can just write it down in your browser and you will be taken to my profile where you can follow me, and my whole schedule will be visible to you along with my whole notes. So that's it for today's class. Again, thank you for watching. Best of luck for your preparation, and stay safe, take care. That's it for today's class.